Welcome, guys. I think I should be online now. I'm happy to greet you to MajorDom's fifth DePIN workshop. Today we will talk about MEP-3355, which is a proposal um, which makes it possible that we can send sensor data via the blockchain in an LLM-friendly compressed format. So we are able to don't have to use that much gas for sending these data. And I also will have, or we also will have a look into this little Frankenstein device, which is a prototype I was provided by Moonchain, which is our IoT sensor, which will be provided in soon. And today I will use it to show you how we can interact via blockchain transactions with our IoT devices. Um, yeah, and I think I will start with setting up the sensor. Um, I also have provided the necessary GitHub repository inside of the description of the video, so you should find it there if you would like to follow what I will do soon. At first, we have to change the firmware of the sensor. The main board of the or the microcontroller of the board will be an ESP32, which we will here we have a diagram of it, which we will flash with our firmware. Um, and yeah, I would say we start with this. For this, I was hooking up my mobile phone. I already downloaded the app, which is named here Nordic DFU. It's called here just DFU, and yeah, we will start to look for the file. I already downloaded it. It's necessary if you're working with Android, at least with Android 9 I'm working on currently, that you will provide this zip file in the download folder. I also tried it without providing it in the download folder, and there it couldn't be found. So this will be necessary. Here we have the file. So okay. Yeah, this looks like exactly what I was talking about. So I have the zip. Oh, you can't see what I'm doing. I'm sorry. Now it should be. Why it doesn't work like it wanted to work. Now. Yeah, and I've chosen the wrong. It will take some time, I think, until we are on the same page. Yeah, here I was taking the same file and it doesn't work. I don't know. I took the same. Anyways, after we choose the file, we have to connect our device, our sensor device, with our mobile phone. For this, we will use Bluetooth. And like it's written here, I have to press the user button for this for 5 seconds. Currently, I have to use some kind of little stick for doing this. And when it's pressed 5 seconds, I will be able to choose it as a device. should be. At least. I think I'm using the right button, but I'm not currently totally sure. I will have to look into the tutorial again. 1 second. Or if in my communication where I got the sensor, because I can use. There are 2 buttons on it, and currently, because it's a prototype, the writing is not as it should be, so I have to look for. I think I was pressing the right one. Yeah, the down one. I'm not sure what is the issue and why it wasn't able to connect. Ah, okay, I see what was the issue. I didn't had Bluetooth on. This was the issue. So I have to open Vulture again. I'm not sure why it's gone again. A visor. So I pressed on select here, and currently it's searching for a Bluetooth device. I'm not sure why my PC is that slow. I was doing the same presentation the last week in German, and there it was working not fine, but it was working properly. Um, yeah, so I'm not sure. Now it lays in front of me and shows this, so it will take some time until we see. Um, yeah, there we are. So now I can press the button for 5 seconds, and then we will see the sensor will coming up. Here I already can see it on my phone. Until you can see it, it will take some time. So I choose the sensor, and then I would start the bootload process or the firmware upload process. Sadly, it takes so much time. I was choosing it like 15-20 seconds ago. I'm really not sure why it takes so long. I really have to set up my PC new and have to provide new cooling paste, I think. But when you're using your PC every day, you don't want to open it and risk to break something. Yeah, sadly I don't know why it's taking so long, so I will start the bootloading process on the phone, and then I would think we will have a look into the MEP-3355, which I already told you about. It is a memo format which uses the Brotli compression algorithm for compressing the data. So here we see how the data will be provided in the memo. It will be in a JSON format, JSON object, and here we can see the required and optional fields in these JSON field. So of course we need the format description, we need the version number, so yeah, the right smart contract is interacting, I think. Then we can provide metadata, which is a totally optional field, and then for sure the data, which will be the compressed data in the Brotli algorithm. Yeah, and here we can see how the data would look like when it's not compressed. Each line would represent, like it's written here, one separate data point from which currently, I don't know if somebody of you have seen it. Moonchain also is working on providing a new IoT device, the Blueberry ring. And from this yeah, sensor from this device, we have these data. Currently, we are in the development. I think the beta test will start soon, or is already started. I'm not totally sure. Um, I have also written a small example of how the Brotli algorithm do or is doing what I was explaining to you right now. So for this, I wrote once the sensor data here, um, which will be compressed here and then printed out, and we also have a size comparison, which will use the bytes of the compressed data and also the bytes of the not compressed data, and will show it to us in the print statement. And by this, we are able to see how good this Brotli algorithm will work to really be able to provide data directly to an LLM, and yeah, let the LLM use this data, work with it, and give us the insights it gets from this data. So yeah, for this I will start this script shortly. And here we can see now, here the decompressed data is written. And here we can see how the compressed data will look like. And you already can see just from these 5 lines, we can get a compression rate around 75%. So it really makes sense to use this kind of compression. I also provided another example where I only have this sentence which I multiply by 1000. So I have more data to be able to show you how the compression works when we have more data and how efficient it is when we have more data. And yeah, here we can see that we have a pretty well better or way more impressive compression rate. So I have issues to do it in my head just by looking on it, but I think we have compression rate around 1000, more than 1000, more than 10,000. So no, more than 1000. Sorry. But yeah, when we look into how much data would be sent, if it not would be compressed, it's not less. So all of this. Okay, one thing I have to tell to you about this is because we just have this line of data and we multiplied this by 1000, it is different to compress this data than in a case if we had like 1000 different sentences. In this case, I would think the compression rate won't be that impressive because the compression algorithm just have to compress this sentence once and also have to compress these multiplication. So yeah, this I would have to thought about before I done this example in this way. Sorry for this. Would be more impressive if it's not would be the same sentence, I think. But for giving you an insight, I think it works. Alright, I will have a look onto the flashing process, which didn't work, and I'm not sure why. Just for showing you the inside. So I done it twice and never had the issue which I have now, so I have to do it once more, I think. Sorry for leaving you out again. So okay, yeah, it's pretty much behind. It's pretty bad behind. Sorry for this. I'm not sure if it makes sense with this at all currently, because yeah, I think I will just make a new connection. I think this makes more sense. Transfer files. And I have to enable the, oh no, here we are. Okay. And play. Yeah, the summer temperatures are not nice when it comes to my laptop. It doesn't like it that much. Okay, now we have to press the user button again. Five seconds, then the sensor will show. Again, I can see it on the mobile phone. Oh, now the connection is better. Okay, so I selected it. We'll start the bootloading process and uploading process. Maybe the issue was that the mobile phone went into standby, but I don't think it, because the app should work in the background also. But anyways, I will touch for now on the display so it doesn't will happen again. Sorry. Yeah, currently we're around 50 on the mobile phone, 50%, so 15% behind on the screen. Looking good so far. Yeah, I just want to use this silent moment to thank for your for the 200 subscriptions which happened in the last 2 weeks, 3 weeks. Um, so yeah, thank you for this, and I hope you like what you've seen so far. I would love if you give some information about the things you want to see more, or things I have to explain further or introduce more. Um, be so kind and leave a comment for this. Alright, so here we can see that we're currently done. And with this, I think we are able now to cut the connection with the mobile phone and instead use, sorry, I'm on the wrong page, and instead make our purchase of the provision ID, which we will need to connect our sensor with the smart contract on the blockchain, and for making it able to interact just with these sensor and not with all the sensors which are working with these smart contracts. So we have to get an ID, and for this we have to set up a trash mail, or you can also use your business mail or something like this if you want to. Sorry. The issue why I use a throwback mail or a trash mail is just for the reason that this email address will be shown on the blockchain, and for not being spammed totally. Yeah, I think this decision makes sense. Alright, then we can go over and set up a putty on my side, I have to use putty. For the people which will use Linux, um, they can use Minicom. And yeah, oh, all right, I can. Sorry, standing on uh, to set up Visual Studio. I had it opened before I started the stream, but sadly I closed it again because for purchasing the PID we have to interact with the blockchain already, and yeah, sending our email there. Yeah. Okay, yes, of course I had Visual Studio code open. I was working with it already in the presentation. Um, okay, whatever. I have to work further with Linux. I don't have a good opinion with working on Windows and not totally being able to know what my processes are doing and if they only are doing what they should doing and not doing some malicious stuff. Like, I'm not sure if I closed Visual Studio, but don't think I did it. Anyways, I hope um, it will be set up soon, so we will be able to purchase the PID. I will set up the comment for this while it's loading. So we have these three comments which are important for now. The first one would be for checking the profile, the device profile, which is explained more here in the tutorial. So we have to check the index have to match with the profile or with the firmware data which we used, and following the tutorial this will be counter 3 or will be the integer 3, and I think for purchasing, yes, we have to set these integer once more. The first integer will be how many PIDs we want to purchase, and yeah, the second transaction would be a transaction to check the price of the PID or of one PID. And yeah, so currently we are able to purchase a PID. So I'm not sure if I would be able to use the send command without. I would think yes, because I was using Anvil also and it worked without setting Foundry up again. I have to work with it more. Sorry for this. So yeah, currently we're waiting until Foundry was initiated. Yeah, no, I think I would have been able to just do the command, this one. So we will send a transaction to this smart contract address using this function, providing our email address as well as two integers. The first for how many for how many PIDs we want to purchase. The third one for which firmware we want to use, or which sensor profile we want to use. which is working with the smart contract, or which the smart contract is. Yeah, sorry, I don't have the right vocabulary. Um, and yeah, then we have the needed primary key, private key, as well as the value which is needed to do the transaction. All right, we do this, and then we should get an email with an CSV file on the trash email, which will take some time. But one good sign will be that the transaction went through. Sorry. And after we purchase the PID, we will then use this PID to interact with the sensor via PuTTY, or like I said further, when you would use Linux, Minicom. I can do some settings currently because we have to set the baud rate from the standard configuration to this one, and we also have to set off or don't use any flow control. Don't wonder why already serial COM3 is chosen here. In my case, this is the COM connection I have to use. Okay, PuTTY connection is working fine. Then I just will wait until I get the email with the PID as well as the CK-EVM hash. And when we got these, here it is, we will be able to set these PID on our sensor, and with this we will be able to interact via blockchain transactions with our sensor. And in this example, we will be able to switch off the LED, or make it happen that the LED cycles and turns on and off. Yeah. So here we can see the PID as well as some other data. From this, in this example, only the PID and the PID ZK-VM hash will be necessary. So for now, I just take the PID ZK-VM hash and use this for setting up the next comment. Here we have to set in the PID. Now we copy this comment and send it to PuTTY. So this was taken from it. Now we can use the reboot command to reboot the sensor. And while this is happening, we will be able to mint our sensor NFT for being able to interact with it. Sorry, for this we have to use, of course, Visual Studio again, and we'll use this command. No, not this command. We will use this command as well as the PID ZK-VM hash. We will use this one for the next comment, for all the next comments. So for interacting with, not for interacting, for minting the sensor as well for interacting with it. So here we also will set it so we directly have these 3 comments ready. I just will mint it and then I will explain a bit more for the comments. So while the transaction is going through, we will have a look into the mint transaction. Of course, we have to set the smart contract ID of the NFT factory, I would say, of the smart contract which mints our NFT. Then we have here our ZK EVM hash. I'm not sure for what this integer is. Here we will provide the URI of the NFT, our RPC URL for sure, the private key, as well as the value which will be needed to mint the NFT. And here we see the transaction went through successfully. And with this, I would say I will be able to change the state of this LED, via sending the next transaction. I think the most interesting will be to make it blink and not only turn it off, which should be working now. So we already have been set up this command via providing the ZK EVM hash. And with this done, we should be able to send the transaction, and in 30 seconds it should be able to stop lighting up the whole time and start blinking. And all this is be done just by these second black box I have standing on my table, which is also kind of prototype of one of our miners, which these two are interacting with LoRaWAN. And yeah, the transaction which will be sent between both of these are also LoRaWAN data. So I'm wondering why I don't see an answer in Visual Studio Code yet. Okay, there the transaction went through. So soon we also should see that the LED will turn off and start blinking. Maybe I have to reboot it once more, but here we are. So, like I said, this was one example how we were able to interact with our sensor via the blockchain. And here we also seen the input which we got, which made the sensor from lighting all the time, or from the LED is on all the time, to switching to being blinking. And just for fun, I also will show you the next transaction, which will set the LED low, which also will take around a minute, 30 seconds. We will see. At max a minute, I would say, and at least 30 seconds. Yeah, and with this done, I hope I was able to give you an insight how we are able to use the blockchain to interact with IoT devices at all, or all kind of IoT devices. And if you have any questions beside the information I already provided, or if I should go deeper in some things I told you about today, I would love if you would leave a comment. And I hope you enjoyed what you have seen today, and I think as soon as the LED will turn off, I also will say thank you for you today, and yeah, hope we will see us in the next week again. Next time, I think we will do the workshop again in German, and yeah, in 2 weeks then again in English. But this is not sure yet. I think I will be able to provide these information on Monday or Tuesday. And yeah, I'm happy if you join the channels I also wrote into the description. We have their Telegram channel as well as the Twitter channel, and I would love if some of you would join there and interact. Alright, so like I said, as soon as the LED will go off, we will stop the stream for now, and yeah,